All right, today's lesson is dealing with using corresponding parts of congruent triangles, or as I told you earlier when we started chapter 4, Cajun people cook tasty chickens. Corresponding parts of congruent triangles are congruent. However, you need to remember that. So we're going to quickly start off with a vocabulary review of the word reflexive. And the reflexive property of congruent states that any geometric figure is congruent to itself. The reflexive property of equality states that any quantity is equal to itself. And so we want to circle the expressions that illustrates the reflexive property of equality. So A equals A is correct, and 5 plus C equals 5 plus C. Both the left side and the right side have to be the same. Similarly, we're going to circle the expressions that illustrate the reflexive property of congruence. Angle ABC is congruent to angle ABC. Segment CD is congruent to segment CD. And remember, if you put this in a proof, you use the reflexive property of congruence. A proof is a convincing evidence that a statement of theory is true. You use statements and reasons to prove whatever you're trying to prove. In geometry, a proof uses definition, postulates, and theorems to prove theorems. No one can prove how the universe started, and he can prove when he bought the computer because he has a receipt. So let's start out with our lesson today with a proof of all things, since we just used the word proof. Complete the steps in the proof. Segment AB is congruent to segment AD, AB and AD. BC is congruent to segment DC. Angle D is congruent to angle B, and angle DAC is congruent to angle BAC. And we want to prove that triangle ABC is congruent to triangle ADC. So we're going to first start out with by what we are given. We're given that AB is congruent to segment AD, segment BC is congruent to segment DC. Finally, because the segment AC is shared in both triangles, we can use a reflexive property of congruence to say segment AC is congruent to segment AC. In addition, we are given that angle D is congruent to angle B, and that angle DAC is congruent to angle BAC. By the third angle theorem, since we have two angles of congruent triangles are congruent, by the third angle theorem, I can say that angle DCA is congruent to angle BCA. So now that I have shown that all parts of the triangles are congruent, then I can say that triangle ABC is congruent to triangle ADC by definition of congruent triangles. But in addition, we can prove that corresponding parts of triangles are congruent. So I have another proof here. I'm given that segment BA is congruent to segment DA, and that segment CA is congruent to segment EA. And I want to prove that angle C is congruent to angle E. So get started. What are the four ways that we can use to prove parts of two triangles to prove that triangles are congruent? We can look at side, side, side. We can look at side, angle, side. In addition, we learned about the angle, side, angle, and angle, angle, side theorem. So we have three postulates in a theorem to prove that triangles are congruent. So prove the triangles are congruent when you know two pairs of congruent corresponding sides. I can either use the side, side, side postulate or the side, angle, side postulate. The given states and the diagram shows that there are two pairs of congruent sides. So let's continue to look at this problem on the next slide. So we're going to finish out this proof. Segment BA congruent to segment DA is given. Segment CA congruent to segment EA is given. Angle CAB is congruent to angle EAD because vertical angles are congruent. If we look at the two angles there, those are vertical angles. So I can say the two triangles are congruent by side, angle, side. Now to finish out my proof, since I've now said the two triangles are congruent, I can say that angle C is congruent to angle E because corresponding parts of congruent triangles are congruent. So all you have to write is CP, but what that stands for is corresponding parts of congruent triangles are congruent. Continuing on to the next problem, we want to prove that triangle parts congruent to measure distance. So, given that AB is congruent to AC, the top of the triangle and the bottom of the triangle, and M is the midpoint of BC, we want to prove that angle AMB is congruent to angle AMC. And you might really want to pay attention to this proof because one of the constructed response questions on the release test for the common test is sort of similar to this one. I'm going to look at the two and compare them, but it looks very similar to this particular proof. So given that segment AB is congruent to segment AC, M is the middle port of segment BC, and using the reflexive property of congruence, I can say that segment AM is congruent to segment AM. By the definition of midpoint, I know that segment BM is congruent to segment CM. So therefore, by side theorem, triangle AMB is congruent to triangle AMC. Now that I know that the two triangles are congruent, I can prove anything about any side or any angle. So angle AMB is congruent to angle AMC by CP, So CP, CTC, got to get all that in there. So angle AMB is congruent to angle AMC. So that's pretty much our lesson. You just got to remember corresponding parts of congruent triangles are congruent. So let's do our quick lesson check. Name the postulate or theorem that you can use to show the triangles are congruent. Then explain why. So we want to why segment EA is congruent to segment MA. Circle the angles that are marked congruent. Well, we have angle T or ETA and angle MTA. And now we're going to circle the sides that are marked congruent. We have segment ET and segment MT. By reflexive property, segment AT is congruent upon itself. So we have a side, we have an angle, and a side. Therefore, we're going to prove these two triangles are congruent by side, angle, side. Now we're going to, since those two triangles are congruent, once again, corresponding parts of congruent triangles are congruent. CPC, TC. Let's go to the second lesson check. Do you understand? So we're going to correct an error. Given that segment KH is congruent to segment NH and angle L is congruent to angle M, we want to prove that H is the midpoint of LM. In order to prove that, we have to prove that LH is congruent, segment LH is congruent to segment HM. The paragraph proof. KH is congruent to NH because it is given. Angle L is congruent to angle M because it's a given. Angle KHL is congruent to angle NHM because vertical angles are congruent. So triangle KHL is congruent to triangle MHN by ASA postulate. Since corresponding parts of congruent triangles are congruent, LH is congruent to MH, and by definition of midpoint, H is the midpoint of LM. Now, the question is angle KHL congruent to angle NHM because of vertical angles are congruent? The answer to that is true. It is. But is triangle KHL congruent to triangle MHN by the ASA postulate? Let's look at that real quick. KH is here, Angle L is here. So I need to, I got it. I've got an angle, I've got a side, but I don't have another angle. It should be angle. I actually have an angle, and a side. So it's not by ASA postulate. So let's try to straighten this out. When you name congruent triangles, you must name corresponding vertices in the same order. To use the ASA postulate, you need two pairs of congruent angles and a pair of included congruent sides, and that's our problem here. To use the AAS theorem, you need two pairs of congruent angles and a pair of non-included congruent sides, and that is what we have. So triangle KHL is not congruent to triangle MHN. The ASA postulate cannot be used to prove the triangle is congruent. But I can say that triangle KHL is congruent to triangle NHM. The letters and vertices must be in the correct order by the angle side theorem. So that's our lesson. The main thing to remember from this lesson is corresponding parts of congruent triangles are congruent. For those of you who didn't do your 4-3 practice sheets in class, make sure you do that homework tonight. We'll go through the 4-2 work and 4-3 work, make sure everything's good, kosher there. And tomorrow we'll work on 4-4. I know we're going through this chapter really quick, but most of the ideas are pretty easy, and I think you guys can handle it. So, see you tomorrow when we will go over 4-4. Have a good evening.